LCU14-209 LLVMLinux. My name is Ryan Arnold. I'm the Lenovo Toolchain Working Group Engineering Manager. This presentation or discussion will be given by Behan Webster, and I believe Renato is going to be speaking
making comments
as usual. You can find the presentation slide deck on Zarista. Also, you can find the link to the Etherpad there. I would appreciate any help with the summary you guys can give, especially if the discussion is good. That being said, we'll have time for questions and discussions at the end. Also, you can go into the chat and put questions there if you want. That goes for the people on the video link as well. In-room questions, I would ask that you use the microphone. That's for the benefit of those who are watching the video and also for the benefit of our archive, for our video archive. So now I'd like to turn the microphone over to Behan.
Thank you. Sure. Yeah. So I'm Behan Webster, the team lead for the LLVMLinux project. So I apologize that the slides on Zarista are now out of date. I will update them again after my talk. I have this terrible habit of having changes at the last minute that seems to go into the slides, so we will make that happen. And of course, I have my pointer off appropriate place. Okay. Cool. So first of all, just talking quickly about the LLVMLinux project. Essentially, the whole idea of our project is to bring in a number of people together who are working on porting the Linux kernel such that it will work with Clang. We're also trying very hard to find problems ahead of time such that we can affect change in both the LLVM project and Clang, and indeed try and fix problems in the kernel before they essentially diverge further from what can build with Clang. Really what we're trying to do is we're trying to enable choice, so to provide the ability to use either the incumbent GCC or a new compiler, essentially Clang in this particular situation, considering how close it is essentially. And we're actually ultimately going to look at the number of problems that are still an issue. So we'll go through some examples here. Our system is based on a set of F scripts. Those scripts ultimately will do things like build the compiler toolchain, build the kernel, apply all the appropriate patches and such. The work we're doing essentially involves a lot of recompiling the same thing and retesting, so we've automated the whole thing. Certainly if you want to use our environment, relatively easy, it's all in Git, download it. We have a number of different targets that you can do builds for directly, and a number of different architectures that are supported. So most notably, of course, ARM and ARC64, although we also have an x86 port, and in fact, we have a MIPS port that's coming along relatively shortly. We also publish a patched kernel tree. Basically, we take Mainline and apply all of our patches on top of it on a regular basis. It does get rebased, so expect that. But ultimately, you can pull in exactly what we had as of today from this particular branch on the slide here. So we try to put all of these things together as much as we possibly can to make these things as accessible as possible. Some of the patches that are in there are not patches that we can upstream. So just bear in mind, some of them are enablement patches, situations where we haven't necessarily found solutions that can be used upstream. Whereas the stuff that goes into our next branch and things like that, of course, are only things that have ultimately made it through the review process. As we stand right now, essentially all things that are absolutely required in LLVM are essentially upstream already. Now we have a couple of things we're still looking at, but as far as the 3.5 release that was just released this past week, essentially with the patches we have for the kernel, you can essentially build with the released version of Clang at this point in time. When we first started this, we had a bunch of extra patches on top of LLVM and Clang. We were at a stage where that was all working, and then ultimately we, well, actually Renato got a change in for us that supported the ability to use named registers for the global naming of the stack. We'll look at that a little bit later. So that actually invalidated 3.4 for being used with the kernel for a while, but now we're back at 3.5. We have all those features upstream. The kernel, the number of patches go up and down, but as of this morning, we have 49 patches across 3 architectures. That's ARM, ARC64, and x86. We'll go through those patch counts, though. So these are existing patches that are still on their way upstream. A bunch of other patches that have been accepted as well, but these are the ones that are sort of in flight right now. Overall, 49 patches. 23 of those are in Arch-independent situations, 12 in ARM, 11 in ARC64, and only 3 in x86-64. Yes, I know the x86 patches are lower. We're trying to enable certain key top kernel developers to be able to ultimately use this stuff such that the base support can get in, such that the ARM and ARC64 patches are more easily sent in. Okay, but otherwise, as far as submitted patches are concerned, roughly 37 of those have been submitted. Many of them have been ACT. 11 of them are currently in maintainer trees.
I just wonder, are the patches involved, or a typical patch, would it be a difficult one or a reasonably trivial change?
Most of them are actually one-liners. Some of them are considerably larger, but we're going to actually go through some of the code and patches in the upcoming slides. But I would say well over 50% of them are one-liners. So, but otherwise, we've got 11 things that are already in maintainer trees that are making their way up. Some of them have been ACT already. So beyond that, we have another 7. So we're hoping to be able to get a lot of this stuff in. I'm really hoping that we're at a point right now where we'll be able to get most of those 37 in for, if not 318, 319. So, and the ones that have not been submitted yet, the vast majority of those are ones where we don't yet have a really good solution, one that's not necessarily something that upstream maintainers would want to have. So,
how many of those would you rather fix in LLVM to be more Regency-like?
I don't have an actual number as to the number that we want to fix in Clang versus the kernel. We are looking into it. The way this usually works is that if something looks like it should probably be fixed in Clang, we investigate that first. As Renato knows, he's got this very silly habit of checking his phone before he goes to bed. And it seems that we have a lot of conversations when he really should be sleeping. But anyway, the point ultimately is that we try very hard to get these things sorted out in Clang. If for whatever reason it doesn't work or whatever else, we try to figure out whether something or not can be done across Clang and GCC in some situations. But more often than not, we're talking about a one-liner change in the kernel versus something that's a relatively large architectural change in the compiler.
Yeah, as a rule of thumb, I always assume the Clang is wrong first, and I try to prove myself that it's not. And then if I can prove myself, then I try to prove him wrong. Yes. And then he tries to prove the kernel guys wrong.
Absolutely. I'm wrong a lot, so I do my best to take all comments on these things. So yeah. Okay. So yeah, essentially we're in a pretty good shape. The problem is every time we kill one bug, the next one comes up. For instance, one of the slides that I actually removed was nested functions. We had completely removed those from the kernel, and another one popped up recently. Fortunately, that one was fixed very, very quickly, and in fact, that one actually made it into one of the patches that just made it to mainline the last couple of days. So we are nested function free again. So that's really good. All right. So just because people wanted to know the absolute number for their particular architecture, I've just done the math here. I'm sure everybody could have done it, but essentially for ARM, we're down to 35 patches. 28 of those are currently in flight. 3 of them have already been accepted upstream, however, not in mainline, right? So they're essentially on their way up, probably in 318. ARC64, we have 34 patches overall, including architecture-specific and Arch-independent. 25 submitted, and 9 are currently upstream. So we're actually doing really well there. x86, again, mostly upstream, 26 patches overall. Again, most of those are the Arch-independent stuff. And I should say, of the Arch-independent stuff, I think 3 of them aren't strictly required. They're merely nice to have. So generating bitcode, for instance, for arbitrary files and that sort of thing. So we're working on a lot of these different situations. Okay, so the big thing here is Kbuild was one of the first things we had to patch. It works fine for x86. We have a couple of extra patches that are in flight as far as supporting general cross-compiling capabilities and such. But otherwise, we have everything upstream for x86. The one to enable ARM cross-compiling and such is in flight. The ARch64 patch, I obviously forgot to update this particular slide. I just got rid of the ARch64 patch rather. So in fact, Kbuild should work with ARch64 without any further changes other than our top level changes. So that's really good. Integrated assembly status. So this is one of our biggest problems and where we actually have the most issues right now. The big problem we have here is that a lot of the code in the ARM tree is written in pre-UL syntax, so pre-unified format syntax. Essentially, Clang supports unified format only, whereas GCC supports unified plus all the various extensions and such from beforehand. So we've actually turned off what's called the integrated assembler in Clang because essentially it does not work in all situations on the ARM tree. Whereas we're pretty close to getting that working on the x86 side. Less of an issue on the ARch64 side, of course, because newer code, but ultimately that's been our major issue there. And we're getting a lot of support from the LLVM team and actually from Linaro in order to get that working, which is good. However, I will point out that in fact most of the compiler crashes we're getting right now are still around inline assembly. So those are usually the issues that we start finding more than anything else. And indeed, we have a if you look at our build bot right now, we have one of the failures we have is on the BeagleBone target. Well, the multi v7 def config build, I should say, really. And in fact, it's an inline assembly seg fault, unfortunately, that we have to talk about still. Yes.
Okay. We can have
we can take questions, sure, yeah.
So you said you have inline assembly turned off at the moment. Is our
IA is turned off. We're using GNU assembler. So the integrated assembler in Clang is turned off. So we're using GAS essentially.
But with the issues to resolve, so those are latent issues that need to be addressed.
Right.
And are those reflected in the patch set or additional work that's needed?
So one of the patches that is in there actually is the patch that turns off integrated assembler. So we haven't submitted that yet because quite frankly we don't want that patch upstream. We want people to be able to work on that, and in fact, for instance, one of the things we complained about that was blocking its use in the x86 tree. I know we don't necessarily want to talk about this, but by leaving it on, essentially, we all of a sudden got a patch from David Woodhouse that fixed one of the major issues. So we're certainly looking for help on that side of things. The problem is that, as we can all appreciate, there's an awful lot of integrated of inline assembly, in these things. And just changing them all is really non-trivial. So we've pushed that piece off for the moment. And the idea ultimately is to enable Clang in the kernel and then to elicit help from the larger kernel community in order to solve that problem. If for no other reason, the issue right now is every change that is made to inline assembly is only being tested in GCC. So it's really playing guacamole until people can try it also with Clang at the same time. So that's the idea. But ultimately, the idea is at least on the ARM side, is to encourage people to do to not use GNU extensions and to do unified assembly only.
So in the integrated assembler area, we're trying to support everything.
Oh yeah, right? That's true, sorry.
But right now, we're starting with the smaller projects like the Chromium. So I'm now trying to get the Chromium compiling with the integrated assembler so they don't have to use the no integrated as option. And that's mostly like asking the library writers to remove pre-UL and to use UL syntax or GNU extensions and everything. And sometimes, so if the pre-UL syntax is just like an alias to a UL, then, well, we just put it in. But if it's something that will require huge investment, then we just ask the guys to not do this. So when we're done with the Chromium project and the other, then, and when he's done with the GAS, right, and when he compiles with GAS and he's working with GAS, then we tackle the other problem, which is make the integrated assembler.
Although I'll just point out that one of our community members, we've actually sicked him on this project, and he regularly builds with integrated assembler and then sends messages to Renato. So
very large messages.
Very, very large messages, and fortunately they're both Brazilian, so that we get away with it.
Yeah.
So, any other questions? We really do want to use the integrated assembler. It makes the compile a lot faster, and ultimately the error checking is significantly better because it's completely built into the AST parse tree mechanism. So as opposed to running an external assembler. So we're motivated to get that working. The point is purely that it is a big enough piece that it's easily pushed off while we enable the rest of the tool chain. So ultimately, I should say those are two parts that we're using still from bin utils, the GNU assembler and the linker, although that's a different piece entirely. That's not actually a problem at the moment. So the next thing is different option passing. So this is just, we've given an example, and this is actually one of the patches, representative one of the patches, again, a one-liner. So we have a situation right now, and in fact, I got a better description of why this is from Renato yesterday. So I'll probably elicit your explanation again in a second. But one of the things we found is that, for instance, when we compiled for AR64, march isn't actually ultimately being passed through to the external assembler, and in part, this has to do with the whole handling of options, either going to the integrated assembler versus an external assembler, and largely has to do with the handling of WA, as far as whether or not that gets read by the internal integrated assembler, or whether that goes through and under what circumstances. And perhaps I should let you explain the rest.
Because for ARM v8, the integrated assembler, and ARM as well, the integrated assembler is turned on by default. Right. And nobody I know is using GAS. With Clang, they use the integrated assembler, except you. And so they just don't pass the WA that they should. So if there's a bug in Clang, it's just probably one line.
Our feeling is that this is a Clang issue, not a kernel issue.
Oh yeah.
So, and I actually asked whether or not we could get this into the kernel temporarily, and the answer from Will Deacon essentially was, if this was the very last patch that enabled the kernel to compile with Clang, no worries. But if there are other issues, then essentially, push back, fix it in Clang, because we still have time. So, yeah. So otherwise, it's fairly innocuous. This does actually work in both cases. It's just that we're not trying to make the code uglier. That's, yeah. Maybe some people think we are, we're not.
And fixing the right place.
Oh, there we go. Thanks, Will. So we actually we can actually turn it on or off per file, and indeed there's a lot of stuff in various architectures that work that way. The problem that it came down to is we had to start littering no integrated assembler all over the build system. It was very difficult because somebody would make a new change to a particular file, and we'd have to make a change to Kbuild again. It was just easier to turn it off everywhere for the moment. So we turned it off at the top level, and then in our patch. The idea is to look at this more later, but quite honestly, there's so many things to look at right now, we've just pushed it off for the moment. So it probably could be turned on, and we need to look at it again on the AR64 side. We only recently got the AR64 Clang compiled kernel working under QEMU, so give us a little bit more time. We'll definitely give it a shot.
You could do it per directory.
You can, and you could do it per file as well. And indeed, the original efforts done on this x86-64 side indeed had it done per file, and we had roughly, I don't know, 50 or 60 different changes across a number of different patches. We decided that it just wasn't maintainable. So for the moment, we said, you know what, we're just going to shut off everywhere, we'll come back to it later. But ironically, whenever we've looked at it, more and more of those problems have been disappearing. So, and I imagine this is much less of an issue on the AR64 side than it is everywhere else. Again, it's just, it hasn't been at the top of our priority list.
So I have a question for the kernel guys.
Sure.
If the kernel has some assembly that is pre-UL, how likely would it be for you guys to try to do this in the UL form so that it can be compiled with the integrated assembler in LLVM, even if it's just like tat-by-tat change that doesn't add anything just because Clang? Would it be something that you say, oh yeah, all right, or you'll be something that, oh, I don't know, it doesn't do anything and it's working like that?
So it's actually the first time that I heard that there's two different ways of doing this. I'm certainly not opposed to changing things when there's reasonable confidence that it won't break anything. It's if you have a trivial change that helps you, it doesn't hurt anyone else. Why not take it? Yes.
Right. It's normally just the name of the instruction.
Yes. Yeah. Perfect. Yeah.
Okay.
I got picked up in review, I think, on unified assembly issues because we have to go back to tool chains that are quite historic, like GCC 4.2. And I'm not sure what assembly is paired up with that, but I'm not sure. For example, I couldn't use push and pop.
Right. Yes. So we have a minimum assembler level that we support, minimum binutils version. As long as we don't have to rev the binutils version that we support, then that's fine.
Right. I think the version of binutils is already quite high because I added those barrier instructions and got yelled at. But I think it's 2.21 or something. But
sometimes it's per platform, sort of like. As long as we know we only need it for this platform, which didn't exist back in those days, then.
So the only thing.
Per platform, so.
Yeah.
The only thing that makes me uneasy about.
But I mean, like the ARMv5 specific code in ARM that would not be per platform. Something that would have to be the minimum level.
Yeah, the only thing that makes me uneasy about changing ASM is when it's, like you say, buried away for some platform, we can't really test it. So it's important to prove that any change we make isn't going to break what's already there.
Right. So if you get the same object code out with GCC as before, then that's fine.
Yeah.
So it's just the object code, it's not the assembler, because the assembler version, is it per, like, is ARMv5 a different architecture in that view than ARMv6 and ARMv7 and ARMv7A and ARMv7M? Are they all different architectures, or is ARM the minimum? So the binutils, the version of the binutils, is that limited by ARM Intel, or is it ARMv5, ARMv6?
It's probably, I mean, realistically, it should be, theoretically, it should be one for the whole kernel, but realistically, it's going to depend on different versions. So, for example, for ARMv7, you're going to need a fairly recent binutils because we've added support for, well, we started using new instructions, for example, which earlier versions of GAS don't accept. But for things like v5, we don't want to, like, if it works with an old version of binutils, we shouldn't break that.
Yeah.
So we try not to break things that worked before. So if people were able to build something with an old binutils version, they should be able to build the same configuration within on the newer kernel. But if there's a new platform coming in and people were never able to build that, and we know by the time that this was merged, everybody has new binutils, then they're much laxer.
Because one of the problems, for instance, is the VFB instructions, right? Before you had to access this like MOVs to VFB and general purpose registers with using coprocessor instructions, LDC and SDC, right? And then there's ARMv5, possibly, I think that was the F instructions, and then ARMv6 or V7 came with the V instructions, and some of them were deprecated, some of them were moved into something else different. So now in the libc++, I had to have, like, if this is before ARMv5, you do this. If it's between ARMv5 and ARMv6, you do that. And if it's V7 plus, you do something else. But we had to if-def all these things, right? And this is ugly.
We should probably keep moving on.
Right, go, sorry.
No, that's all right. This is all good conversation, so it's awesome. We'll try to get through other things. So one of the next things...
Well, just one point on the use of LDC, VMOV, and all the mnemonics.
Fair enough.
If you essentially use the LDC, STC instructions, that's enough. They share the same encoding. In fact, in the libstd C++ implementation for exception handling in GCC, we have LDC and STC so that we don't get into issues with respect to when the libraries are built for V5P soft float and so on.
It's a larger issue than that. We tried to do that and we failed, and now we talk later.
We should probably talk later, that's right.
Yeah.
Thank you. Okay, so the next thing ultimately is, and this is largely gone now, I think we only have one patch left that ultimately does this. One of the major problems is that GCC by default uses an older standard than does Clang. Now they both support the different standards, but ultimately by default GCC now uses GNU 90, which is essentially GNU 89 with a bunch of stuff backported from C99 and then a bunch of extra GNU stuff on top of it. Clang by default uses GNU 99, which essentially is C99 with a tiny bit of GNU stuff on top of it. So this is where we've had a lot of other problems come in. The major one is the difference between what extern inline means. And so again, most of these are now gone, mostly because it was fairly trivial to explain why this is a bad idea. The only patch we still have that ultimately deals with this is in fact on the ftrace side on ARM, which has already been hacked by Stephen Rostat. So we've got some, just got to get that into the tree, but ultimately that's the last one. The big thing here is essentially that extern inline means the exact opposite thing between GNU89 and C99. So it's a matter of moving everything to static inline and changing the code appropriately in those situations. Attribute order. So this is another one that's kind of interesting and one that Renato and I have had a few arguments about. Essentially, the situation is that if you look at the documentation for GCC, you're allowed to put modifiers and things like sections and attributes anywhere. Like, I'm serious, anywhere in the middle of the beginning of a type, in the middle of a type, at the end of a type, end of the variable, pretty much wherever you want. It's really messy. Clang is less permissive and essentially allows it in more than one place, in fewer places. I would argue in more obvious places, because essentially the idea is not in the middle of a structure definition, for instance. So we have probably 3 or 4 patches that do exactly, all they do is they move it around. That's it. And actually, last night I noticed that Andrew Morton took the patch I submitted on Friday, and it's now in his tree. So we have a few more of these patches to put in. The argument was, do we fix this in Clang, or are these one-liners much easier just to get up in the kernel? So far, it looks like the kernel community is okay in essentially moving sections around. Okay, I'm getting a lot of good nods here. Yeah. I have at least 3 other patches, if I remember correctly, that I should send.
So is there a GCC warning that'll tell you that you're using something that's...
No, in fact, this is a documented
GCC has no warning.
If a GCC, or if a kernel developer continues to just use GCC,
this problem will continue, yes. Yeah. Unfortunately, if you read the documentation for GCC, it actually encourages you to put them in the middle of a structure. So the problem is it says put it here, here, or here, but this is where you should put it. And the problem is it's right in the middle of the type def. What would be the type def, rather. So struct, blah, and then the name of the structure.
Have you changed the docs?
Well, I can't, but perhaps the point ultimately is that you need to apply the type to the variable or to the symbol, not to the type, essentially. Yeah. Yeah.
And we can still put those attributes in place of the qualifiers, which is not in the middle of the scope.
Correct.
That goes the same.
Right. Exactly. Yeah. No, it can't be in the middle. It can be at the beginning or the end, but. The ultimate situation, though, is that when you put an attribute, it should be on the variable and not on the type. So putting it before the type doesn't make a lot of sense either. Okay? And again, it can be done on a function or on a variable, but not on the type of those things. Right? If you're not careful, if you put it in the wrong spot, like if you put it before the return code of a function, it ends up being on the return, the type of the return code as opposed to on the function, which is kind of crazy. So, okay. So we have a couple of these ones. Like I said, I wrote this slide, and then of course I had to update it because it just made it into Andrew Morton's tree. So named registers. So this one is largely a solved problem. There's a number of places in the kernel where we name registers such that they can be used elsewhere. In the situations where those named symbols are only ever used in a inline assembly block, which is immediately after it, essentially it's all good. Okay. The situation is where essentially register is named and then ultimately used in C code as well as in an assembly block, where the issue is, fortunately, we only ever do this with the stack pointer. Now, the interesting thing is that on the x86 side, they just removed it completely. With their port to 4.9, essentially, all of our patches were invalidated on the x86 side, so we didn't even submit them. There was no point. And in fact, when we tried to submit... Sorry?
Better in this case just to use built-in stack pointer?
Built-in, the problem is there isn't a built-in stack pointer. There's a built-in frame pointer and return address. There is no built-in. Now the interesting thing is you mentioned that we actually put forward that very idea to add built-in stack pointer to both Clang and to GCC, and in fact we had a patch that we were trying to get into Clang, and then we started working, or Renato actually did most of the work, talking to the GCC guys, as far as they were concerned, Clang was trying to solve a problem in GCC that was getting around a potential deficiency in Clang, or something to that ilk.
Solving a problem that was already solved.
Right.
By using the stack pointer name register.
So Renato actually moved heaven and earth and actually added the ability to globally name the stack pointer, such that we could then add essentially that command to the thread info.h, and then essentially use a global rather than a locally named stack pointer, such that it could work everywhere. So by putting that in there, then essentially making sure we get rid of all the local definitions that look like that, essentially it just works. And that works on both ARch64 and on ARM. Will has already taken the ARch64 patches that do this. So
that's good. That's more retargetable too, because not everybody names the stack pointer the same thing.
This is used in a lot of places.
I have a check for every architecture. Yes. They name their own stack pointer name register.
Yeah.
So then you know.
Totally works.
So long story short, we had a patch for built-in stack pointer. Clang accepted, GCC refused.
Yes.
And then I had a patch for built-in for named registers. Clang refused. And then I have a patch for named registers that the only named registers could be the stack pointer, and then they accepted.
That's right.
So.
And since that's all we need for the kernel right now, I'm happy. So, and it's now
a lot of politics.
It's now 3.5, and so what turned in, essentially what is essentially a one-liner change in a number of places in kernel code is now a few dozen lines in Clang to support a single version, but it actually takes us to the point where we're in the same place we were on the x86 side before they removed it all, and that was essentially global definition, which is then used everywhere. Point is that essentially, to a large degree, everybody's happy now. So that's a good thing, and the code still reads nicely, which is the big thing that the pushback we got originally. So originally we tried to do this inline assembly, and it was ugly, really, really ugly. So next one is we have the only final place where the stack pointer is being used where this doesn't actually work very well is the per CPU patch. And the issue here essentially is that it used to be written as it is down here. Okay, the problem is that does not work with GCC, and so it was written this way. Okay, that doesn't work with Clang. So the situation we have now essentially is trying to decide how this ultimately should work. We have a patch that ultimately chooses which line that gets used based on whether or not you're using Clang or GCC. Really, we would prefer to see the problem fixed in GCC, but we're thinking this one might actually, actually the recent versions of Clang, did we actually get this working again? Oh, right, yeah. No, I think
I redid this, so there is a fix for this. It just uses the syntax, but it can use the stack pointer. Now
that's true.
It's a global variable.
That's true. This slide was written 2 weeks ago. That's changed since then. Okay, fair enough. Sorry, this isn't an issue anymore. This was one of the issues we had, I should say. So moving on. Thank you. This is one that we're still having troubles with. Essentially, in Clang, we do not support the %A in inline assembly. So the issue that we have ultimately is in ARch64 when we do, I forget which file this is in now, but when we do a PureFM, essentially the line at the top here is what we have for GCC. The issue ultimately is that we get an error when we compile with Clang. The problem is if you move over to %x, which was the suggestion, then we get a bug in GCC. So again, we're in a situation where it's a one or the other kind of situation. This is the proposed patch that we have to solve the two situations where we come across this kind of issue. Essentially, to replace the %A with %x for an index, and move from a P to an R pointer to register. The problem here is that this isn't necessarily something that everybody wants to see. So we're looking for a better solution at this point.
So as a GCC guy, I'm fairly sure that I took a look, or someone from the Linaro team took a look at this GCC problem, and at least the test case had a bug in it. So it might be a real bug in GCC, but the test case reduced from the code was not correct.
Okay. Well, we're going to have to look at that further then in any case. This is something we do not have a good solution for yet, one that everybody likes. So that's cool. All right, the next one is section mismatch issues. We still have a few of these that come up. The big problem more than anything else is that mod post doesn't necessarily understand what it is that that Clang is doing. One of the issues that we got around by essentially turning off this feature is Clang will merge global variables into a single register table, which is then can be accessed based on an offset from a single register. The idea here ultimately is that you don't have to keep everything in its own at its own address or whatever. The problem is that mod post essentially tries to see whether or not there are section mismatch errors where regular code calls init or exit code at the wrong place, and it's a matter of probably ultimately fixing mod post in order to properly understand how the merged table works. But for the moment, we've turned it off. However, we still have a number of warnings that come from mod post in related kinds of situations. Again, it's trying to do the right thing. When we look at these things, typically the issue more than anything else is that it's a false positive essentially. But this ultimately is something we want solved because it'd be really nice to use merged globals. It makes the code smaller and faster. But like I said, without mod post being fixed, ultimately, this isn't something we can easily do. So this is the next one, AEABA support. So I actually pushed 2 patches for this on Friday, one for ARM, one for AR64. It was pointed out, in fact, that this patch is not required anymore for AR64, so that was an easy one. We just removed the patch. It is still required on the ARM side. The situation essentially is that ARM defines the AEABI such that Clang essentially is using these particular symbols in order to call memcopy, memmove, and memset. Now, as far as fixing the memmove and memcopy situations are concerned, we could potentially get around those with some linker magic, just renaming the symbols. The problem is with memset is that the parameters are switched. So that is one of those situations where we need a wrapper. So right now we're creating a file that ultimately wraps all 3 calls. We do not have a better solution for it at this particular point in time.
Why did no built-in fix
So
this?
I do not know why no built-in doesn't fix this. The other one that Barrow actually suggested yesterday was freestanding, although we tried that and unfortunately it still emits those
I
particular
think that's a
symbols.
bug in Clang.
Okay, well, it's the first time you said that, so.
Yeah, because if it's not, if
Not
the
doing
flags are
built-ins.
not working, they should be working.
Hey, I'm happy if we can get that. Unfortunately, that means that we have to wait until 3.6 until that part can be solved. But
Just create a bug in LLVM.
okay, all right. Well, we will definitely do that. And we're down to our last major issue. This is the one that I'm currently banging my head against the wall with, and that is variable length arrays in Structs. And this is the one that most people laugh at me as they walk by my talking to other people at conferences like this because they know what I'm talking about. And it's always that variable length arrays, no problems, they're supported, they're in the C standard, no issues. As soon as you put it into a structure, however, that's actually forbidden by the standard. And it causes all sorts of problems. Essentially, Clang will not add it because it is against the standard. It was added to GCC years and years ago for various reasons. I've heard conflicting stories from different people, but ultimately this kind of functionality is important in the GCC toolchain to support languages such as Ada. So my theory is that it was feature leakage into GCC. I've been told by GCC developers that it was a feature. It was not actually a documented feature until extremely recently. One of the reasons that Clang gave for not supporting it beyond the standard issue is that it was not documented. It was actually documented in 4.9. So from that perspective, at least, we're very happy that we were able to help in that respect. But as far as using VLAIS in the kernel is concerned, it does preclude the use of Clang. And I think there's a question at the back which we'll go do before we continue. Your question?
I believe it was added for glibc.
For glibc, I'm okay. That's the first I've heard that.
Yeah, me too.
I think I did it.
Okay. Awesome.
Now we know how to kill. Yeah.
Okay. Well, that's probably the truest answer that I've heard so far. Then. So.
I think we don't want to do that in the kernel.
Okay. Every kernel developer I talk to doesn't like this. In fact, whenever I show this to various maintainers, they all wrinkle their nose up and go, "Ew." So the problem more than anything else is replacing with something that's not too terrible. And so we've gone through this a few different times. The big thing ultimately, again, is as soon as you put a undefined length into an array in a struct, that's when things blow up. Even at the end, if it's a zero-length array, that becomes a flexible member. That's totally supported. As soon as you make it variable, that's when there's problems. Okay. So the last thing is supported by C99. The problem is that you have to look at 3 different sections in order to realize that it is in fact supported, but nonetheless. So this is the standard way of doing it. Now, the second part, this is actually our old patches from 2 weeks ago. I now have patches that use a macro to hide this. We originally tried to remove LAIS in a number of situations with macros, and various maintainers told us, don't hide your pointer math in macros. We want to see what's going on. And we recently posted this to the crypto groups, and the various people are using this, because I think we've got 11 patches that do this. And they said, for God's sakes, hide the ugliness in macro magic. So, okay, so we now have a macro that hides the ugliness in a macro that does this. And hey, we're just trying to solve the problem here. So we have a macro that now does this specifically for crypto, no other place. Our previous attempt was actually to solve the problem generically, but this is a targeted solution.
It's called crypto underscore something.
I can't remember what it's called. It's shash desk on stack or something like that. Thomas Glexner suggested the name, so I'm just going with his suggestion because it was his concern that we are mostly trying to solve. In any case, that's basically the deal. It also bubbles through, unfortunately, so we have to make a number of small changes. That is the major change in each instance. Unfortunately, this design pattern is used across the kernel everywhere where crypto touches it. And so, fortunately, a number of places like EXT and Bluetooth and AppArmor, they've taken our patches already. We still have a number of crypto-only situations where it needs to be taken in. Yeah?
We have 2 minutes left.
Yeah, we're almost at the end. Okay, so essentially, if you want to see the rest of what's going on here, essentially the deal ultimately is that shash has attributes in it that align it appropriately such that the end of the structure is aligned. We then make sure we align the whole thing such that ultimately the character array that is used to replace this is properly aligned on all architectures. The code that's missing to understand that is on the next slide. We won't go through it in detail. The big thing ultimately, though, is that the LAIS has now been removed from the USB gadget driver, from the 802.11 driver, NetFilter, AppArmor, Bluetooth. I'm probably forgetting a few. The ones that are left over are ButterFS, DMCrypt, hmac, libcrc32, Test Manager, and a few others. The holdouts largely are saying we want to do whatever the rest of the crypto system does. So in principle, they agree. They just are waiting for the solution. Okay, whereas the other guys have more or less said we're happy with what you have so far. Okay. Now, and I should say ultimately, those were the only places we knew where LAIS was being used in the past. Unfortunately, we just found a few others in the last couple of weeks. This is the most egregious of them all. In the exofs situation, yes, it's an eye chart, but it is not only just multiple uses of LAIS, it is nested uses of LAIS. So it is a second order variable length arrays and structures. It is truly awful. I have no idea how we're going to patch this. What I'm hoping is that we can enable get the community themselves to solve the problem. But the number one thing I've heard from everyone is, who uses exofs? I'm not sure that's a valid argument.
No, but revert the patch that introduced this.
So this isn't the only place. It's also used in RAID 10. So there's like a couple places. The problem is it starts to touch enterprise code. So that's starting to get a bit scary. So. Okay, so the big thing is, how can you guys help? First of all, don't do these things. Okay, for God's sakes, I don't want to have to patch your code. So please use C99 constructs wherever you possibly can. Don't do things that merely work in GCC. If you can turn on C99 compliance and see whether it works for your stuff, great. Ideally, compile with Clang. It's really not that hard. Yeah. But the point ultimately is that we're getting rapidly to a point where any kernel developer can essentially take what's in their distro and build, and that's ultimately what we want to enable. We want to know about bugs. If something's not working properly, if we're doing something dumb, we want to know, okay? Patches accepted, we've got a mailing list, bug tracking system, we've got a build bot that generally goes through all this stuff and jumps on us when we've done things that aren't working. We always compile with GCC first and then Clang, because if the minimum bar isn't reached, in other words, if we're breaking the GCC build, that's not acceptable. So we always build both in our build bot. We do not want to disable anything. We're trying to enable alternatives here. But ultimately, you know, whatever help that we can get from the community and from other people to make this work, the better. But otherwise, yeah, embrace the dragon.
Can I add two things? So can you go back to the back? More. One more. Right. The big problem here is that he identified this piece of code as wrong because of the VLAIS, but actually, what this does is a struct of two things, and then they pass a pointer to sh to a function, not a pointer to the struct desk, a pointer to the sh, right? And the function knows that in the structure after where sh is, there is a VLAIS.
Yes.
And he accesses the VLAIS.
Yes.
Right?
We're running out of time, so
the VLAIS here is not the bigger problem. Right. The second thing is how you could help is there was a situation a few weeks ago when one of your patches broke the ARC64 build from Linaro.
Oh yeah, about a month and a half ago, yeah.
Yeah. And then someone, I don't remember if it was you or someone else came complain, oh, these guys committing patches and breaking stuff. So, I know.
It wasn't.
Oh no, it's just a joke. The thing is, one thing we could try to come up, not here, somewhere else, is in a way that whenever you have a patch, we can, because you don't have ARC64 to test.
Hardware yet, no.
Yeah. So now we have the QEMU, that's great.
QEMU,
yeah.
which is good.
But we also know that it doesn't mean they will run on hardware.
Correct.
Right? So, and in all the configurations, the Linaro builds are not the same number as the U build.
Correct.
So if you I think we had this conversation before to try to have, like, you have a branch that is upstream something Linaro, and then we picked it up and run on the configurations we have, and then say, oh, it's safe.
Right.
In the ARM ARC64 side to commit.
We have a four ARM and 4 ARC64, and the idea ultimately is to keep the patches that are required there so that people can just pull those directly. We do not have build bots on those yet, so I can't guarantee that they're ultimately working. The problem that came up that Renato's talking about is essentially we have a number of patches that are not upstreamable that we have to put in there just to enable us to be able to build. We are by no means trying to say that those patches should make it into mainline. They're there to make the compile work for the moment. So we're not trying to get people to take, you know, if it says do not upstream in the subject, we're not trying to upstream that particular solution. That is a bug that we're still trying to fix somewhere.
So I've got to run to my next meeting, but I have one question. So do you have an idea of how many warnings you get for an all-mod config build that we don't get with GCC, and how many of those are actually false positives or real bugs?
So essentially warnings are something that we jump on and then more pop up and so on, but we test primarily on vExpress and vExpress64, and there's essentially dozens of warnings in each situation. We started off with a lot more, so we're getting rid of a lot. We still have to go back and add patches in order to get rid of some of those warnings. The vast majority of them are false positives. So there are situations where essentially Clang is more rigorous than GCC. So it's not strictly speaking that there are problems, but they potentially could be problems. And a number of them are situations where automatic casts are done between. So things are upcast or downcast automatically that potentially cause problems. So
that's actually a very helpful one that we try to fix.
It is.
GCC14-209 actually introduced a whole lot of false positive warnings for things that are correct and that nobody else warned about before. So that's been really annoying.
Right. We've actually turned off a bunch of warnings that Clang thinks are a good idea too. Things like comparing signed to unsigned, tautological things and such. Pretty much wherever the kernel community has decided that it's a bad warning, we've tried to turn it off. But more and more, we're actually removing those things because, quite frankly, the kernel is generally heading towards an area where those warnings aren't happening anyway. So, which is very good.
And we have new config options in the kernel that let you turn on extra warnings, and you might want to look at.
We've tied into that. Yeah. Cool.
All right, thank you, Behan. Thank you. I think it's